Now coming to chapter 2, which is on time value of money. Now time value of money simply means a rupee today is worth more than a rupee tomorrow. This is because of the purchasing power parity theory. That is, rupees 100 will have less purchasing power after 1 year than it has today, mainly because of inflation. It means that you will be able to purchase more goods today with rupees 100 than an year later. This is time value of money. Means a rupee today is worth more than a rupee tomorrow because of purchasing power parity theory. Rupees 100 will have less purchasing power after 1 year than it has today, and the reason is inflation. Now, inflation is a condition in which the average price of all the goods and the commodities increase on an average. It means that you'll be able to purchase more goods today with rupees 100 than an year later. The various concepts that we are going to learn under this chapter are: first is future value of a single cash flow. Future value of single cash flow. Future value of an annuity. Third is present value of single cash flow and present value of series of cash flow. Starting with the very first topic, that is future value of single cash flow. The future value of single cash flow can be calculated using the following formula. Future value for the nth period is equal to the present value 1 plus r raised to the power n, where future value FVN is equal to future value for n years, PV is the present value, that is the cash flows, R is rate of return, and N is the total number of years. These were the various terms. Now let's take an example here. Let's take an example. Suppose you invest rupees 1000 for a period of 5 years in a bank. Suppose you invest rupees 1000 for a period of 5 years in a bank, the rate of interest is 10%. Find the future value. Now future value in this case will be, we noted down the formula on the last page. Future value for nth period is equal to present value 1 plus r raised to the power n. So present value in the given case is rupees 1000, that is you want to invest rupees 1000 today. So PV is rupees 1000 here. R is rate of return, is rate of interest is 10%, R is 10%, and N is number of years, that is for a period of 5 years, N is 5 years here. So putting this in the formula, 1000 1 plus 10 raised to the power 5. So let's calculate this. This is 1.10 into 1 2 3 4. 1000 multiplied by 1.61051 into 1000 is equal to 1610 rupees 1610.51. So the interest earned on an investment of rupees 1000 is rupees 610.51 in 5 years. Interest earned on an investment of rupees 1000 is rupees 610.51 in 5 years. And how did we get this 610.51? That is, we got rupees 1.61.51 at the end of 5 years, and we invested rupees 1000, so which gives us an interest of rupees 610.51. Now some of you must not be aware how to calculate this 1 plus 0.10 raised to the power 5. So if you open this up, this will be 1.10 into 1.10 into 1.10 into 1.10 into 1.10, that is 5 times. So on calculator, add, this is add 0.1021, that is 1.1, and then press into and equal to for the 4 times, 1 2 3 and 4. This is the amount, so you will get it 1.61051. Coming to the second concept in this chapter is future value of an annuity. Future value of an annuity. Now annuity refers to a series of cash flows or series of payments. Annuity is series of cash flows or series of payments. Let me write it down over here. 1.10 into equal to 4 times is equal to 1.61051. Now annuity can be of 2 types, a regular annuity or an annuity due. Now annuity can be of 2 types. It can be a regular annuity, or ordinary annuity we can call it. Or there can be annuity due. What's the difference between these two? In case of regular annuity or ordinary annuity, the payment or receipt occurs at the end of each period. Payment or receipt occurs at end of each period. And in case of annuity due, the payment or receipt occurs at the beginning of each period. Payment or receipt occurs at beginning of each period. Now, future value of a regular annuity is, first of all, we'll do the future value of regular annuity. That is annuity in which the payment or receipt occurs at the end of each period. This is future value of an annuity. A denotes for annuity, is PCF, periodic cash flows, 1 plus R raised to the power n minus 1 and the whole divided by R. This is the formula for calculating the future value of a regular annuity. Let's write down its components. FVA is equal to future value of an annuity. PCF is periodic cash flows. R is the rate of return. And N is number of years. Let's look at an example on this. Example. X contributes rupees 5,000 every year for life insurance premium for a period of 20 years. X contributes rupees 5,000 every year for life insurance premium for a period of 20 years. Consider interest at 8%. Interest at the rate of 8%. Calculate the future value. Now solution, this is okay. Now first of all, identify that this is an annuity. That is, series of payments are to be made. That is rupees 5,000 every year for a period of next 20 years. Okay, let's write down the formula first. Future value of annuity is equal to periodic cash flows 1 plus R to the power n minus 1 divided by R. What is periodic cash flows? That is the payments that we have to make regularly, that is every year, 5,000. PCF is 5,000. 1 plus rate is 8%, 0.08 to the power 20, and is the number of years, minus 1, and this is to be divided by 0.08. Okay, now let's calculate this. This is 1 plus 0.08 raised to the power 20. So 1.08 into and equal to for 19 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So now we have calculated this component. 1 plus 0.08 raised to the power 20 minus 1 divided by 0.08 multiplied by 5000 so this gives us an answer of rupees 228810. We have rounded off this figure 0.82 as 10. 2,28,810. Alternatively, you can directly get the future value interest factor for an annuity FVIFA at the rate of 8% for 20 years from the future value annuity table, that is 45.762 that we had calculated using the calculator, or you can calculate using the calculator using the method I told you earlier. Okay, now whatever is asked in the question like interest rate or number of years, you can put the given component in this formula and find out the missing values. Like if the R is missing, you can place the future value and the periodic cash flows and can calculate the value of R or the value of N, whatever is missing in the question. So that was about it. Next is future value of annuity due. Future value of annuity due. Annuity for which cash flows or installments occur at the beginning of each period is known as annuity due. Annuity for which cash flows or installments occur at the beginning of each period is known as annuity due. And the formula for its calculation is FVADN is equal to ordinary annuity future value into 1 plus R. This is future value of annuity due for n periods is equal to ordinary annuity future value that we've just calculated, and that is to be multiplied with 1 plus R. This is quite simple to calculate, so we'll not do an example on this. Coming to the present value of single cash flow. Okay, this is page number 11. Present value of single cash flow. Present value is just the opposite of future value. In future value, we do compounding, and in present value, we do discounting. What is present value? Opposite of future value. In future value, what do we do? Compounding. And in present value, we do discounting. Suppose you have a receivable at the end of year 1. Finding the value it has today is known as discounting. you have a receivable at the end of year 1. Finding the value it has today is known as discounting. Formula is present value is equal to future value for nth period divided by 1 plus r raised to the power n. You have, I think, clear with these terms. P is present value, FVN is future value for nth period, n is number of years, r is the rate of return or the discount rate. Rate of return or your discount rate. Let's take up an example. Okay, so here's the question. What amount should be invested today in order to receive rupees 1000 5 years later at 10% rate of interest? So all we have to do is to apply the formula that we learned just now. The formula is present value is equal to future value for nth period, the whole thing divided by 1 plus r to the power n. Okay, so present value is equal to future value is 1000 divided by 1 plus r is 0.10 and for a period of 5 years. Let's calculate this. 1.10 into 1, 2, 3, 4 memory plus 1000 divided by memory recall and equal to 620.92 rupees 620.92. Now for calculating the value of 1 plus 0.10 raised to the power 5, you can refer to the present value table or can do it using the calculator. Coming to the next topic under this chapter is present value of series of cash flows. Page 12. And this is present value of series of cash flows. Present value of series of cash flows. There can be two things. There can be an even series or an uneven series. First of all, let's take up an uneven series. So let's do it by an example. Suppose you have the following cash flows for 5 years. Suppose you have following cash flows for 5 years. Year 1, 2, 3, 4, 5 and cash flows are 2000, 5000, 8000, 2000 for 4th year and 3000 for year 5. Now cost of capital or discount rate given is 10%. Cost of capital or discount rate is equal to 10%. What you have to do is to calculate the present value. Calculate present value. Now let's see the solution to this. The first column will write down the year. This is calculation of present value. 1, 2, 3, 4, 5. Cash flows 2000, 5000, 8000, 2000 and 3000. Now this what it means by this is this 2000 is standing at year 1. We have to calculate the present value for this. So we'll multiply these with the present value factors and we'll calculate it. Present value factor at the rate of 10%. Let's see how to calculate this. This is calculated using the calculator as 1 divided by 1.10 because we are calculating the present value factor for 10%. So this is 1 divided by 1.10. The first is 0.909. Keep writing it down simultaneously. 0.909. Second, all you have to do is press the equal to sign. Equal to, this is 0.826. 0.826 simultaneously for the rest. 0.751 equal to 0.683, again equal to 0.621. For calculating the present value, you have to multiply cash flows with into present value factors. So 2000 multiplied by 0.909, 2000 into 0.909 equal to 1818. Second is 5000 multiplied by 0.826, 4130. 8000 multiplied by 0.751, 6008. Next is 2000 multiplied by 0.683, 1366. And last is 3000 multiplied by 0.621, 1863. 1863. Let's add all these. Says 1818 plus 4130 plus 6008 plus 1366 and 1863. 15185. So this is the present value. Wasn't that really simple and quick? That was for an uneven series. Uneven series means the cash flows are not equal every year. They are different. You'll receive 2000 rupees at the end of year 1, 5000 at the end of year 2, 8000 at the end of year 3, and so on. Coming to the present value of an even series. This is the second part. Present value of an even series. This is quite simple to calculate. Suppose we receive or pay rupees 2000 for 5 years. Suppose rupees 2000 is the cash flow for 5 years. The discount rate is 10%. So simply we can calculate this cash flow into present value interest factor for annuity, 10% for 5 years. 2000 into, we have to calculate this, this is again 1 divided by, so you can directly get it from the table also. So let's just do it. You already know how to calculate this, so let's just pick it up from the table itself. This is 3.791, 7582. So this is how you can calculate the present value for an even series. So this was about chapter 2.